I'm going to talk a little bit about WiHi, but mostly, it's an idea we're having at the moment, and we are very open for feedback. So it's like work in progress. It's not finalized, but this AI-based data valuation. We're going to talk. Fire. Okay, so I'm now with WiHi, weather intelligence, trying to do, and we see we have many problems in the world. One of them is weather, extreme weather conditions, and the narrative is kind of that we need better in weather intelligence for all types of applications, to mitigate such events in the future, to maybe also to react to them more quickly. But also for newer applications, for example, when you have drones flying, they need to kind of know exactly how the weather is. So it's a growing market in some sense, and in this very moment, this weather prediction market is kind of disrupted. So traditionally, it's also where my background is coming a little bit from. It's these very high-performant, very expensive, large clusters, with the meteorological organizations usually. The biggest supercomputer here in Switzerland is usually also used for weather predictions. So this is heavily research-oriented experts doing all these physical modeling of the real world, trying to predict the future. But now what is with AI is happening is there's some form of democratization. So there are new models to predict the weather with AI, and the interesting thing is it's very cheap to run them. So maybe not so cheap to train them, but once you have that model, inference is quite cheap. So this cost of compute for weather prediction is going drastically down, and we also see these open source movement in these models, so to say. So also getting access to these models is quite cheap. So the only thing which is really the thing which is missing is the data, which is the main cost, and also the key ingredients. So those who have better data will improve their prediction capability. And when it comes to weather, what we observe is that data is actually quite siloed, and that we have a lot of data which is already freely available. So the classical DePIN approach with incentivizing people placing weather stations or something like that can be maybe done in some regions and maybe to densify in some others. But in general, meteorological organizations all over the place are sharing this high quality data. And the problem is now when we start now incentivizing new data, these are usually hobbyists, and the data quality will be much worse. Yeah, so there's really this problem of where to place incentives, and at some point, if maybe the network matures, so we have a lot of incentives for other actors, maybe private entities to join, then the quality could also rise again. And in general, in the existing industry, there's no real data market out there for weather data. Yeah? So people are saying they would like to have better data, but no one is paying for it. But we see there's not really a private weather company selling weather data or something like this. So it's really, and we have seen also in other domains, usually data markets are not too existent. Onokoi is talking in parallel. There I would say we have some exception of existing data market, but in general, they are not there. And which might be, it's my co-founder, a very messy slide, but what he's basically saying is that we always say big data is the new oil, but in the end, data really has no value. We have massive amounts of data all over the place, and we don't even have the computational power to analyze this data. One can make these theoretical arguments. The data is growing more quickly than computing power, so we're collecting data, but no one is ever going to look at it. So it goes more to a high quality data, contextualized data, which that's basically where one needs to go to. And this is kind of how we see it now. So we're also thinking a lot how to, this data network we are building, kind of this classic DePIN 1.0 maybe, how to enhance it. And then we said okay, we add an intelligence layer on top, and the intelligence service are in the end what will drive the value. So we have data contributors improving our modeling. Then we have our intelligence services, which provide value to the token, and then we can incentivize data contributions. However, I think this is kind of the open problem in the space in general. How do we incentivize correctly? Yeah? So if we over-incentivize, then we give a lot of equity already away to our contributors very early. And if we have rewards in general in the system, people will try to game it, yeah. And so, what is actually the qualities of the data we are collecting? How to value the data? Is it malicious? Is it not malicious? Is it even good data? In the context of weather, what does it mean, good weather data? So like you have a weather station here, and 5 meters down, you could have another weather station with a different microclimate if there's a tree or a building or whatever. So it's very difficult to say what is the right data if it has been tampered with. And I think in few DePIN projects I've seen, it's really clear what actually the value of the data which is contributed actually is to actually price it, yeah. And here comes now our thinking a little bit. It's very preliminary, but it's a joint collaboration with the University of Zurich. We have a group of students basically pushing for this. But we basically say now, look, we have these AI models, and these AI models, they give us a forecast. Yeah, and they're like these explainability methods in AI, in machine learning. So basically we can trace how much data input contributed to an output. So we know at this location, for this model at least, these data points were important and others are less. Yeah, so and basically through backwards engineering, through this in-model approach, we can kind of start quantifying if we want to have a better prediction in this location, we know which data points actually would result to it, and then one can start incentivizing those contributors a bit more maybe than others and have a more flexible incentivization scheme. It sounds maybe a bit abstract, but if you look for example, these are two weather models which are used. One is ForecastNet, one is Pangu weather. And they have a different architecture, but we see here, at least for this model, we take kind of data points also in consideration which are quite far. For this one, which is more transformer based, you kind of have this grid around these points, and this gives a lot of problems to this intuition, this idea to use the model to quantify the value of data. And the limitation is that it's only purely in model. But our thinking goes now in the direction to overlay, to see maybe take 4 or 5 different weather models, see which data points are maybe important for a forecast, and then start incentivizing in this direction. It's very experimental, so I'm just sharing. Any feedback from anyone, most welcome. And in the second step, we then want to kind of connect the model forecast with the real world forecast, and then maybe through some derivatives, in this regard, trace the error again, and then also see, if this actually really makes sense. But that's what we are up to at the moment. And we have some other things which I'm not going to talk, which are maybe already a bit more working. But the main idea is now that we want to incentivize this comprehensive collaboration, getting data, but really high quality data in these areas we need, by really linking the rewards to the contribution of the data. And so this solves this incentivization problem. We have a lot of works. The slides will be shared on different aspects of DePIN, me and my 2 co-founders. Feel free to check them out. That's Uroš, really good in tokenomics, and Michael, computer scientist, and me, trying to connect maybe both worlds together. And if you want to exchange or have some view on collaboration, either from research, we're very much into research, but also from industry, if you have some solutions which could help, let's connect and talk. That's it. Thank you very much.